All right, one of my favorite units in AP Environmental Science, Earth systems. In many places, human land use contributes substantially to the rate of erosion. Poor land use and practices like deforestation, overgrazing, unmanaged construction activity, and road building can create this accelerated period of erosion time. And so, erosion usually leads to depositing this eroded material somewhere else, and that can cause even more additional environmental problems. So we'll discuss human caused erosion further. But soil has a number of functions that benefit organisms in an ecosystem. Soil is the medium for which plants grow. It also serves as the primary filter for water and water movement, from the atmosphere into basically rivers, streams, and groundwater. Soil also contributes greatly to biodiversity by providing habitat for a wide variety of living things, even bacteria, algae, fungus, insects, and other animals. And it also acts as a filter for pollutants. It filters out chemical compounds that are deposited by air pollution and even household sewage. And some of these materials remain in the soil, and some of them are released back into the atmosphere or even into groundwater. So let's look at the formation and properties of soil. In order to really appreciate the role of soil in an ecosystem, we need to understand how and why soil forms and what happens to soil when humans alter it. And it takes hundreds of years for soil to actually form. So soil is the result of physical and chemical weathering of rocks and the gradual accumulation of detritus from the actual biosphere. We can determine the specific properties of soil if we know what the actual parent rock type was and the amount of time it has been given to actually form. And it is associated with biotic and abiotic components. So in this figure here, you can see that there are stages of soil development. It starts from rock all the way to mature soil. This process that forms soil works basically in two directions simultaneously. The breakdown of rock and primary minerals by weathering provides the raw material for soil to form. And the organic matter from organisms and their waste contributes to soil formation as well. I'm thinking of earthworms come to mind because they basically move through a matrix and out comes soil, right? What we normally think of as soil essentially is a mixture of the minerals and organic components. So a poorly developed or young soil has substantially less organic matter and fewer nutrients than a more developed or what we would call mature soil. Very old soils may also be nutrient poor because over time they've removed plants, they've removed the essential nutrients from the water, and from the soil. And also, lots of water has caused the minerals and nutrients to leach away. And so, five factors are happening simultaneously that determine the properties of soils. They are the parent material, the climate, which we're talking about, the topography, which is like their landscape, organisms, and the amount of time. So the organic matter that you're looking at here comes from organisms and their waste products. And depending upon who's there, we can see that over time soil becomes more mature, and also it becomes more plentiful. The rock substrate itself has been broken down. There essentially was a parent rock, which was weathered and fragmented, and then organic material started to accumulate. Plants die, leaving their detritus behind, and so greater amounts of organic material continue to be deposited, and now we see in mature soil lots of that. So again, there are five factors that determine the properties of soil: the parent material rock, climate, topography, the organisms that are present there, and the time it's been given to develop. Parent material is the rock material from which the inorganic components of the soil have been derived of, like we discussed earlier in this unit. Climate influences the soil formation in two ways. Soils do not develop well in temperatures that are below freezing because the decomposition of organic material and water movement is extremely slow when it's very cold. And so nothing's going to happen there. And so soils at high latitudes, like in the northern hemisphere, are composed of largely organic material and they're under decomposed. In contrast, soil development in humid areas has accelerated and rapid weathering and basically all of the rain that has happened there has leached nutrients out. And so the climate also has this indirect effect on soil formation, just because of the types of not only vegetation there, but how much rain and things occur. Topography, like the surface of the area, the slope, and the arrangement of the landscape, is also another factor for soil formation. Soils that form on these real steep slopes are constantly subjected to erosion, and on occasion, more drastic mass movements, like what we talked about, plate tectonics and landslides, can also affect that. Soils that form at the bottom of slopes may continue to accumulate higher and higher dense soil material over time. And so, it's just in contrast, we can have really, really poor soil or really, really high nutrient soil just based on topography. And organisms, like many organisms, influence soil formation. Plants remove nutrients from the soil and secrete organic acids that that speed up chemical weathering. And animals that tunnel and burrow, like earthworms and gophers and voles, they mix the soil uniformly, and that distributes organic material throughout it. So collectively, soil organisms act as like a recycling component, like recycling organic matter. And in the process of using dead organisms and their waste and their energy source, when things die and degrade, soil organisms break down organic matter, detritus, and release mineral nutrients back into the actual soil itself. Human activity has dramatically affected soils. And for centuries, we have used and overused the land for agriculture, forestry, and we've also led to really, really significant soil degradation. Time's the final factor here that determines the properties of soil and the amount of time it has been and basically what stage of development it's in. So as soil ages, they develop a variety of characteristics. Right? The grassland soils that support much more food crops and livestock, feed production in the United States. Right? Because they have had continuous inputs of organic matter over hundreds of years, grasslands and prairie vegetation can grow things really, really fast. They've become extremely fertile. Other soils that may be equally as old but be less productive can be due to like the landscape there, which has over time great water movement, water's moved through them, and it's made them basically infertile. So depending upon what we're looking at here, over time it should become like better and better soil, but also too over time it can become more and more eroded or depleted. As soils form, they develop a characteristic horizon, which is the horizontal layers. They're very distinct physical features like color, texture, specific composition. So, with these horizons or characteristics of soil, there are 5. From the top down, we have the O horizon, which is the organic matter at the very surface. It's comprised of a lot of organic detritus, and it's got various stages of decomposition going on. And then the A horizon is frequently the top layer of soil, and it's at a zone where the organic material and the minerals that have been mixed together real evenly. We call that topsoil. And then the E horizon, that's a zone of leaching and alluviation found in just some soils, not every soil. really acidic soils actually. It lies just underneath the O horizon, and even less often the A horizon. And kind of what's happening there is where minerals have leached in due to a lot of like water percolation. We just have this dry, kind of gross, sandy layer, and we call that the E horizon. All right, so the B horizon is a soil horizon composed primarily of mineral material, and there's very little organic matter at that point. And then we have the sea horizon, which is the least weathered of all the soils. And that is basically parent rock and parent material. All soils have horizons or layers, and they can vary in size and thickness depending upon where you're at. And soil formation factors and climate also contribute to the depths of each of these horizons. You also have to consider, like we said, organisms, and then of course the parent material we started with in the first place. Most soils have either an O or an A horizon, but not usually both. And some soils that have an O horizon also have an E horizon, and so they're kind of often married together. Dun, dun, dun.